video, we're going to try to quickly address the idea of energy and energy conversions. So at the end of the physics unit, we start to get into some more complex scenarios. And one of the things that's hard to understand is that energy can be described as kinetic energy, it could be gravitational potential energy, work. It can be described as energy as chemicals. But at the end of the day, when we look at the mechanical energy concept, like that's the total kinetic and potential energy, we talk about roller coasters. We talk about where does it have the maximum potential energy, and if we don't have any friction occurring, then the kinetic energy at the bottom would be the same as the potential energy here. And in the middle, the potential energy and the kinetic energy would be the same amount as those two other values. And that's because we can convert energy, but we can't destroy it. We will lose energy as heat due to friction. So we don't get 100% efficiency, and that's really important to know. But if we're not paying close attention to that small amount of energy lost in many cases, so in machines often it's quite a bit of energy, but if we're kind of ignoring that, we can draw the connection that if this is in joules, this is in joules, and this is in joules, well then those things can be compared to one another. And so if I'm talking about this person who is going to jump 3.2 meters up, which I don't think is possible, and he weighs 75 kilograms, well, I could calculate the potential energy it takes to go from the bottom to the top, right? The potential energy is going to be his mass times gravity, which is a constant on Earth, times height. And that's the energy it takes to go from the ground to the top. And I know that because I can calculate the potential energy when he's at the top. But that same amount of energy is the energy it takes for him to jump that height. So if you were going to go from here to here, if he's collected this potential energy at the top, but his kinetic energy is zero, then his kinetic energy at the bottom is the same value. And so at the top, his EP is the same as his EK at the bottom. And if I wanted to find, his velocity, mgh is going to be equal to the guy's mass times his velocity squared divided by 2, because these two things are the same value. They're joules. So now if I wanted to focus in on this, I can now start to calculate his velocity because I could calculate this, right? I know what his mass, I know what the height is, I know what his gravity is. And so because the potential energy and the kinetic energy are the same values, I can start to get a little bit creative about it. And if I wanted to then talk about, well, what work did he do to get up there? Well, that's the same value too, right? It's still the same amount of energy. It's just the energy he took to travel that distance. And work is force times distance. So now all of a sudden we start getting the connection that in this scenario, the force times the distance that he travels is the same value, right? And so if I wanted to calculate the force times distance equals mgh, well, his force is going to be equal mgh divided by the distance, which is the same as the height. So we start to get, all of this starts to blend together because of this fundamental idea that we're converting energy from one form to another, and it's going to be the same amount of total energy as long as we're not losing too much energy to friction. And so that concept allows you to talk about his work if I know only his potential energy. Or I could talk about the kinetic energy as he falls and is about to hit the ground, because that's related to his potential energy. And so understanding that these connections are all part of the whole same system allows you to go between these different values where I've got mass and velocity, or mass and gravity and height, or force and distance traveled, and be able to connect them, because at the end of the day, joules and joules and joules are the same kind of energy, and if it's connected, we can pull them together. And so we can compare the kinetic energy in one point if we knew the work to get there. Or if we knew the potential energy as you're at the highest point, then I know the work that the ground will do on you as you hit the ground, right? And so understanding that allows us to ask more interesting questions without just giving you only the variables that you would need to exactly fit that formula.